Today's lesson is 10.3, GCF, standard form in degrees. So GCF stands for greatest common factor, and the goal today is to factor by using greatest common factor and rewriting polynomials into standard form while identifying, that's what the idea is, degree of the polynomial. So it kind of goes back to 10.1's lesson about degrees. We're going to use that a little more in today's lesson. So first, we're going to do some greatest common factoring, and what that is taking out the largest piece that happens to multiply into each term of the polynomial and taking it out, right? It's basically backward distributing. Like just for example here, we'll show you 3x squared plus 9x, right? What do they have in common, right? First, for number, 3 goes into both 3 and 9. So we're going to have 3 that we're going to divide out of each piece. But we're not done yet. We haven't looked at the variables yet. So next we have 2 x's and 1 x here. What's the most amount of x I can take out from both pieces, right? The most amount of x is 2, but this second piece does not have 2 x's to take out. So I'm left with each piece has at least 1 x. So we're taking 3 and an x out of each piece. And what do we have left? We 3 divided by 3 here, right? Number first, 3 divided by 3 is 1. And then x squared divided by 1x, right? One of those x's is going to go away. So subtracting 1, I'll have 1 left over. And so I'll have 1x left over. Next piece, we've got 9 divided by 3 gives us 3, right here. 9 divided by 3, kind of cut it into the piece you need, is 3. And then x over x is 1. So they would cancel each other out. And so I get 1x plus 3 is left over. Now, that is not factored, because what happened to that 3x? This 3x, both of them, right, are just going to come out and be on the outside. And so now we have 3x times x plus 3. Now, that 1 is in dotted lines, because you won't need to write it, right? The only reason I wrote that is because 3 divided by 3 was 1, and we hadn't quite finished finding out what we were taking out, right? What was left over. Because there's an x there, we can just leave it as x. Instead of 1x. Now, as a quick double check, your answer should be able to multiply, right? If we quick distributed, here's our answer, by the way. That's what I'm talking about. But if we quick distributed, right, 3x times x is 3x squared. 3 times 3x times 3, 3 times 3 is 9, we have 1x. We should get the same piece we started with, right? Those match. Right, so they should be equivalent pieces, right? We are not changing the value of this. So we got 3x squared plus 9x and match the original. So 2x squared plus 4 is next, right? What do they have in each piece, right? So I see 2 and 4, they both have a 2 in them, so we can divide by 2. Variable-wise, though, I only have x squared and I have nothing. I cannot take anything out. Right? The last equal part, we had 1 of each at least. This one, I have no x squared, right? You want to write 0x squared. But literally, we have no x's, right? So, because of that, we cannot take x out, and our answer, we're just going to divide by 2, and then what's left over, right? So again, remind you, whatever's coming out goes to the outside, and then whatever's left over is on the inside. Okay, so 2 divided by 2, 1. X squared, so that's just 1 x squared. 4 divided by 2 is 2, the sign comes with, and we've got 2 times x squared plus 2. And again, your mini check would be, you can multiply it out and make sure you get the same as your original. 2 times 2 is 4. What do you know? They matched, right? But square your answer so that I can tell you, oh, there's our final answer, and my double check worked. So we're doing a little bit more factoring here. So 6x squared minus 24x, right? 6, 24. 6 goes into both pieces. Next, the x's. We've got 2 here, 1 here. Again, can only take out 1. What's the most x we can take out? 1. And then as you get going, it's a little quicker. 6 over 6 is 1. X squared over x is 1x. And then again, the 6x is on the outside, right? And then what's left over? The minus 24 divided by 6 is minus 4. The negative sign comes with, right? X divided by x is 1, so I just get x minus 4, and my answer is 6x times x minus 4. And it's a little arrow above the top. That's not necessarily part of the solution. Next one, We'll start explaining a little less. 12 and 15, they both are multiples of 3. So divided by 3, we only have one x, so nothing can come out there. And so 12 divided by 3 is 4, and then the x comes with. 15 divided by 3 is 5, and it's minus, so the minus comes with. And there's our answer. Next one, 9y squared minus 81y. They both have a 9, 9 and 81, multiples of 9. And then 2y is 1y, we can only pull out 1 each time. So we get 9y, 9y squared over 9 is 1, y squared over y is y. The y's cancel on the next one, negative 81 over 9 is minus 9. Next, we got 24 and 18. So some of the patterns we've been seeing is the larger number is second. It's not always true, right? That's what this example is showing you. 24 and 18. Well, 8 and 3 go into 24, but 8 doesn't go into 18. 3 does, but it's not our largest number, right? So a method that you can help with is there's this thing that I've heard called the L method, and you can just kind of look at what goes into each piece. Like, what if you don't see it right away? So we kind of do this L, this is the L, and then let's say we saw a 2 for now. We see they're even, we saw a 2, dividing both these by 2. It's kind of like an upside down division sign. I get 12 here, 9 here. Right? And technically we can even bring the y squared with it, but just for number wise, I'm kind of looking at it like that. Now what's in both 12 and 9? Maybe now you see that 3 goes into both pieces, right? And then divide by 3, I get 4, the y squared comes with, 3 goes into 9 3 times, and it was separated by a plus sign. And so now, what's our answer? So it's kind of a neat way of doing it. But our answer is 4y squared plus 3 is what's in the parentheses, and 2 times 3 is what's outside the parentheses, which is 6. And so this is 6 times 4y squared plus 3. Sorry, I forgot that 4 right there. 6 times quantity of 4y squared plus 3. And that was the L method. So we'll try that on the next two for those who might have a hard time of asking or seeing what goes into both pieces. So L method now. Right, what's in both 25x squared minus 5x? Right, now I usually deal with the x last. So 25 and 15, they both have a 5 at the end, so we're going to divide by 5. And I get 5x squared, and then 5 goes into 15, 3, and the minus comes down x. And now 5 and 3 are done. Like 3 doesn't go into 5 and vice versa. 5 doesn't go into 3, right? And now how many x are in each piece? We got 1 here, 2 here. I can only pull out 1 because I can't have a negative number of x. So taking 1x out, we got 1. Over there, we don't have any. We just have the 5. And that's what's our parentheses. We have 5x minus 3, and then times 5x on the outside. One last time, 49y squared plus 28. They both have a 7. 7y squared when we divide by 7, and this is what we're doing here. We get plus 4y, and now 4 and 7, right? No numbers going to them. So now we're taking out the y's, right? I've got 1 in each that can come out, 2 in the first one, and so I get 7y left over and plus 4 left over, right? This was like dividing by y. And so my end answer is 7y times 7y plus 4. Moving on to the next type of question is going to be questions involving the degree, the leading coefficient in a standard form. Now, some of these terms you have heard before. So the degree is the largest exponent, okay? The leading coefficient is the coefficient of the variable with the degree. And the standard form, as a reminder, is we list all the variables in order from greatest to least in terms of degree. And that's what we're talking about, greatest to least degree. Okay. Now, what the questions are going to be is they're going to ask us, given any kind of a mismatch of a polynomial, it won't be in standard form, they'll want us to put it into standard form, they'll want us to identify the leading coefficient and the degree. And so there's going to be a nice quick way you can do this. So, there's our directions. Write the polynomial in standard form, then state the leading coefficient and degree. So what you want to do is below these terms, you want to write the degree of each term, and then whichever one has the highest degree is going to be listed listed first. So for example, 5x squared, degree 2. X to the 5th, degree 5, right? It's the exponent. X to the 3, degree 3, 7x. And minus 12, degree 0. And then you're just going to go through and what's the highest number, right? It's pretty straightforward. 5 is the biggest, so I'm going to write x to the 5th. And I'm just going to kind of check it off. Dotted line. Now that we're done with 5, what's the next largest number? I've got 2, 3, and 0. 3 is the next largest, and I'm going to write plus 7x to the 3rd. Now the sign comes with it, right? This is technically plus x to the 5th, but because it's positive, I don't really need to write that plus sign out front, which is why I'll circle it, right? It is positive, you don't need to write that. Next, what's biggest remaining out of 2 and 0, right? 2 is larger, so we're going to write plus 5x squared. And lastly, minus 12 is the only one left once we cross that one out. And there is our standard form. Notice our degree should go down from largest to smallest, 5, 3, 2, 0. Now, leading coefficient. That's what LC stands for. You just take this this x to the 5th. The first term, I'm taking that and the number in front of it. I don't see a number in front, so how many do I have? I have 1, right? Technically, whenever there's nothing there, it's a plus 1. So our leading coefficient is 1 x to the 5th. And the degree, we just erased those, but that degree was 5, and so the degree is 5. And that is not necessarily just the degree of the leading term, that is the degree of the whole polynomial. However, the leading term gives us the most information. And by leading term, I mean this whole 1 x to the 5th. Next one with a little less explanation, same idea. So writing down our degrees, 4, 6, 2, 0, 1. Now from greatest to least, 3x to the 6th, checking it off. 4x to the 4th, checking it off. Minus 5x squared, check that one off. Plus 7x, because 1 is bigger than 0. And then minus 5 left over. And then leading coefficient, right? I box my leading term, because that's going to be used for the next 2 answers. Leading coefficient is a number in front. I have 3x squared, x6, pardon me. So 3 is the leading coefficient. The degree is the exponent. Right, a little reminder, exponent, and so that is 6. And that is as simple as it is. Pretty straightforward, pretty quick, doesn't take a lot of time. One more, I recommend pausing the video and trying this on your own, and then resume the video and see if your answer matches. And the answer, the 3, 0, 1, 2. So the minus comes with minus 8x cubed minus 6x squared. And the x is 1 plus 2x, and then plus 3. Right? I don't see a sign there, but just like my other one, if there's not a negative, we assume it's positive. Leading coefficient is how many x cubed? I've got minus 8. And then my degree is x cubed, so 3. Did not box at that time, but you could box or circle as a reminder to help you that the next 2 answers are coming from there. The last 2. Again, give yourself a chance to try to answer them. You can pause it for that. Filling out 1, 0, 4. Even though it's negative in front, that doesn't change the degree. And moving on to this one. Let's do all degrees at once here. Now, least degree, greatest to least, minus 25x fourth, minus 19x cubed, plus 10x, plus 17. Right? As you get better, you might not need to cross off what you've done. Right? And there's only 4 terms, so not too bad. The leading coefficient is minus 25, the degree is 4. And then over here, we've got 9x to the 4th, plus x squared, minus 12x. 9 is our leading coefficient, 4 is the degree. Make sure you do the assigned homework on Google Classroom, and feel free to email me any questions you have regarding the lesson or homework so that we can answer them during our next Zoom setup.